To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. Whether you've been programming for 30 minutes or 30 years, you are going to run into bugs. And by bugs, I mean errors in your code, not actual bugs. Although in 1947, engineers did find a moth stuck in the Harvard Mark II, so I guess both can be true. Videos like these can kickstart your coding skills, but learning how to find, understand, and get rid of bugs is one of the best ways to practice programming. Fixing bugs in your code is called debugging, and it's a valuable skill that people put right alongside things like Java proficiency and Excel wizard on their resumes. I'm serious though, if you can't debug, your programs probably won't run. But you're in luck, because debugging is really just problem solving, which is basically the heart of programming. Hi, I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. Computers always do what they're told, so a fun thing about programming is that you know it's your fault when your code is full of red error messages. Humbling. But bugs are a totally normal part of the programmer lifestyle, and knowing what types of errors exist can help us get better at debugging our code. Broadly, there are three main types of bugs: syntax or compile errors, where the computer can't follow what your code means; runtime exceptions, where the program crashes before it's done running; and logical errors, where the program doesn't do what you expect it to do. Unlike human languages like Japanese, Urdu, or American Sign Language, programming languages such as Java, Python, or C# require perfect grammar, or syntax, before the computer can execute the code you write. Syntax errors are a violation of grammar rules, and they are incredibly common. Even the smallest deviation from the rules will cause an error and your code won't compile. The compiler is like a translator that converts high-level, human-friendly programming languages like Java into low-level machine instructions, the zeros and ones that a computer can work with. The compiler does all of this according to the rules of each specific programming language in order of operations, which we talked about in our episode on programming expressions. So the compiler can't do its job unless you perfectly follow the syntax rules. But luckily, if there's a syntax error, the compiler will tell you what and where the error is. That is very nice of you, because I make syntax errors all of the time. How am I supposed to remember a semicolon after every line? I digress. Syntax errors are actually some of the easiest bugs to fix, unlike some of these other errors we'll learn about. For example, let's say that there was a very cool and motivated programmer who was also super prone to making mistakes. We'll name her something random like, I don't know, Sabrina. So this Sabrina wants to test her new Java compiler by printing hello. Clearly she did something wrong because an error message pops up. The most important parts of any error message are the location and the error type, which will help us find and fix the bug. In this case, Java's compiler tells us that the error location is in the file named main.java near line 3, and the error type is a missing semicolon that Sabrina was supposed to put in at the end of a statement and that the compiler expected but couldn't find, because she's only human. The caret even points to exactly where the compiler thinks the error is. In other words, where the missing semicolon should go. All we have to do here is add the missing semicolon at the end of the line, and we're up and running. Classic Sabrina, who is definitely not me. Even if a line has perfect syntax, it might not make sense though. This happens in human language all of the time, like if I say he made a tasteless lasagna that tasted too much of tomato. A human friend could ask a clarifying question to help me fix this tasty, tasteless word vomit situation. But when a computer is faced with something that doesn't make sense, the program might just give up and crash. Relatable. These bugs are called runtime errors, runtime exceptions, or just exceptions for short, because the compiler won't catch them. Java only finds them when the code is actually run. To practice debugging a runtime error, let's check back in on our intrepid programmer, Sabrina. Right now, she's working on a concept called indexing, which is basically assigning an ordered index number to each character in a string or item in a list. Indexing organizes all your data so it'll be easier to search through later. For example, to index the word goblin, we would divide up the letters and give them each a number, counting up. Intuitively, you might assign the letter G an index value of 1, O would be 2, B would be 3, and so on. This system is called one indexing because it starts with the number 1. But most programming languages, including Java, use a system called zero indexing. As you can guess from the name, this system starts indexing at 0 instead of 1. So G would be index 0, O would be 1, and so on. This is definitely a mindset shift, but you'll get more comfortable with it as you practice. Anyway, back to Sabrina. She's using the char at method in her code, which returns the character at a specified index of a string. Specifically, she's testing a function that stores and prints the last character of the word goblin using indexing. But unfortunately, something's not working. This time we're getting a runtime error message to help us find the problem. The string index is out of range. In other words, the number Sabrina specified in the char at method is not a valid index for the string, which in her case is the word goblin. So let's take a closer look. And there's our bug. Sabrina used the index 6, probably because goblin has 6 letters and she's used to counting by 1 indexing. But Java uses 0 indexing, so the last index of goblin is 5, and there is no index 6. To debug, we just need to supply index 5 to the char at method instead of 6, and it runs fine. These runtime bugs can be more difficult to solve than syntax errors, and sometimes we need to read the error message carefully to go further back in our code and figure out where the problem started. Java can help us out with that too. This whole situation at the bottom of the exception method is known as the stack trace. It records the method call that caused the error, along with all the previous method calls that led up to the error. Think of the stack trace as a pile containing everything that happened in your code, with the most recent action on top, the one that caused our error. On this stack trace, the top message shows string Latin1 in java.lang, which means that the Java language java.lang had a problem with a char at method, and this char at method was called on a string that uses the Latin alphabet. The next message tells us that the char at method was called on a string variable. This is talking about our word variable that held the string range. And the last message tells us that the whole thing started in a file called main.java with an uppercase m inside of a function called main with a lowercase m on line 4. In a long program, it can be painful to read through all of this jargon, but having the patience to sleuth your way through a stack trace can help with some of the trickiest bugs. There's one more kind of error you'll run into, and unfortunately, they can be even more tedious than syntax errors or runtime errors because they're untraceable. Java can compile and run your program fine, so there's no error message to save you. You only know that there's an error in the first place because your program does the wrong thing. Why would you do this, computer? I thought we were friends. These bugs are called logic errors or semantic errors, and they happen when your code doesn't produce the intended results. Logic errors can be caused by a complex chain of events, a wrong variable, or something straight up missing from your code. They're subtle, hard to spot, and the bane of many a programmer's existence, including our hardworking, all too human programming friend, Sabrina, who also might be starting an artisanal lasagna fork business. Would you invest? Hello, sharks. Sabrina recently wrote a function to help her business with product orders to ship out. It takes 2 arguments, the product cost and the order status. If the order status is shipped, this method adds a shipping cost of $10.50 to the product cost and returns the total combined cost. If the order status is canceled, it simply returns 0. When Sabrina shared her hard work with her teammates, they just replied, missing returns. Now Sabrina's sure that her method's return values work as expected, so that's not a problem. But upon further clarification, they were pointing out the fact that her code has no way to handle orders that were returned by customers. Basically, there's a logic error in Sabrina's code. There's nothing wrong with the syntax or methods in her code. The problem is that important functionality is just missing. To fix this, we can add an else-if statement for orders with return status that subtracts the shipping cost from the old product cost. Now customers won't pay the shipping cost for something they return. As a best practice, Sabrina also adds an else statement to tell users when they enter an order status that isn't supported by the code yet. This way, her coworkers will know if another order status needs to be added. Speaking from experience, as you learn to understand and debug Java error messages, you'll start to anticipate some common bugs and stop them before they even happen. Or at least laugh a little when you forget yet another semicolon. That being said, if you're running into an error, the odds are high that someone else has had the same problem too. So if you only take one thing away from this video, remember, you are not alone in the debugging process. If you're feeling stuck, try looking up an error message on Google or a dedicated programmer resource like Stack Overflow to see if someone else has worked on or even solved your problem. This can be a huge time saver and is almost always informative. And hey, someday you can contribute your debugging discoveries, silly mistakes, and cringy jokes back to the programming community too. Like, for example, by becoming a YouTuber and sharing your silly little projects with the world. Sure, it can be embarrassing when people catch errors you missed, but that's one of the best ways to improve your program and your skills. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, check out gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.